So Aniruddhan, what shall we do next?
Okay.
We have got some idea.
We have got some idea. So, shall we do sinusoids? Because I'm thinking we have done DC, U of t, turning on a switch, ramp.
Correct. In fact, this is the one we mostly use. Correct.
Mostly use also. Correct.
So sinusoid, how do you represent
in the Laplace domain?
Okay. Is it? Can we use some of the ideas? I mean, some of the transforms that we already have.
Correct. So we have done just U of t.
Yeah.
We have done ramp.
Yeah. Those may not be. It's difficult to connect with sinusoid.
Correct.
Then we have done e power at.
E power at. Correct. So we know that it gave us 1 by s minus a.
Yeah. In one of the classes, you were mentioning some identity.
Correct. Euler's identity.
Okay.
Correct.
Which is also called
complex.
As
that's true. It's an exponential.
Yeah.
Correct.
So then that is some way of representing this sinusoid in e power term.
In e power terms. Correct. Okay.
Then life may become easy.
That is true. Let's try.
Try.
Sure.
So we Euler or
Euler.
Euler.
A lot of people say Euler as well.
Okay. So what is it saying? E power plus or minus j omega.
J omega is cos.
I can write j omega t also.
J omega t. We need j omega t.
Yeah.
E power plus or minus j omega t
is
cos omega t plus or minus j sine omega t.
Okay.
Yeah, I think in mathematics we learnt it as e power I theta is cos theta plus j sine theta.
Correct,
or I sine theta. Mathematicians use I, but we use current
J.
for I, so we use j. Correct.
So that means I can just rewrite to get cos omega t in terms of.
Correct. Yes.
Okay. So maybe just for ease of writing, I'll write separately. So if it's e power j omega t, that will be cos omega t plus j sin omega t. Minus j sin omega t. Okay. So that means if I can maybe let's say 1 and 2. So if I can do 1 plus 2, this will go away.
Correct.
Okay. We were talking sinusoidal. I mean, if we are getting cosine, that should be
correct.
Fine.
Correct.
So what we are saying is 2 cos omega t is equal to e power j omega t plus e power minus j omega t. Correct?
Yes, correct.
So this 2 I can bring it here.
Correct.
I will erase. Correct? Huh?
That's right. This is correct.
So this means I can maybe get sine wave also this way.
Correct. And I think
take
subtract, right?
1 minus 2.
1 minus 2 will give you. Seems like it will give you sine omega t. Correct.
Okay. So 1 minus 2.
Yeah.
I will just write it again.
Yes.
So e power j omega t. I'll write here. E power j omega t minus e power minus j omega t.
Yes. It will be 2j sine omega t.
2j sine omega t.
Yes.
So we want sine omega t. I'll bring in this 2j here. And remove from here.
Correct.
Oh, I think this makes the life easier.
Yes.
Correct, no? So because we know how to deal with e power.
Yes.
So if we had, I think in the previous, e power at is 1 by s minus a.
Correct.
Let me write that. E power at in the s domain, it is 1 by s minus
Correct.
a.
Correct.
So let's try for cos omega t.
For cos omega t, okay.
So what we are saying is this Laplace transform of cos omega t.
Okay, it will be the Laplace transform of
e
this,
power
no?
j omega t.
Okay.
So how will I write? That will be e power. No e power. No e power.
It's not no e power.
It
will
is
be
only
1 minus
1 by.
s minus j omega.
Yeah. So this I can just write it as 1 by a replaced by j omega.
J omega, correct. So it will be 1 by s minus j omega.
Correct.
Okay.
Plus 1 by
s plus j omega. And then you
because
need a
it is s minus a.
S minus a.
Divided by 2.
Divided by 2. Correct.
Okay, so we can take, so this will be s plus j omega minus s.
No, plus s minus j
omega. Oh, so this is plus, correct. S minus j omega.
Correct.
Divided by s square
plus omega square.
Plus omega square.
And you also have a half.
1 by 2.
1 by 2 at the outside. Correct.
So these two will get cancelled.
Correct. And even the 2 seems to get cancelled because you have s plus s.
Oh, this is 2s.
Correct.
Okay. Can I write here?
Yes, yes.
So this is coming as s square.
S by s square plus omega
s
square.
by s square plus omega square.
Perfect.
So cos omega t is giving s by
s square
plus omega square.
Okay.
I don't know what it is. I mean, but
it is giving us this, no?
Yeah.
So we have used only two properties.
Correct.
We have used this e power at.
Correct.
And then we have also said, we have the sum of these two functions. I mean, when you integrate it, it will just give you the sum of the individual Laplace transforms.
Correct.
That's all we have done.
Correct.
Right?
Yeah.
Correct.
Yeah. So should be correct.
Correct.
So this is f of s for cos omega t.
Yes.
Okay. So now we will do for sine.
Sine.
Again, we will use our technique.
Technique, no?
So e power is 1 by
yes
s minus j omega.
Correct. But now we have a minus 1 by s plus j omega.
1 by s plus j omega divided by 2j.
Divided by 2j. Correct.
So this is s plus j omega minus s plus j omega.
Correct.
Divided by 1 by 2j, I will keep here, s square plus
omega
square. So s and s will get cancelled.
S and s will get cancelled.
J and j will get cancelled.
Correct.
2 and 2 omega in the 2 will get cancelled.
2 will get cancelled. You will only have omega in the new
omega by s square plus omega square.
Perfect.
Okay. Yeah. So the cos and sine, only the numerator there is a change.
There is a change. Denominator, there is no change. So cosine has an s in the numerator, sine only has an omega in the numerator.
Maybe that's a way to remember.
That's a way to remember also.
Cos.
Correct.
S in the numerator.
Correct.
Yeah. Nice. So this is, I mean, one of the widely used input signals. So it's good to remember this.
Correct.
Good. So we have Laplace transform for sine and cosine.